friends, today I will discuss the single phase induction motor, no load test and the block rotor test. The connections for the single phase induction motor, no load test and the block rotor test are like this. This is the single phase auto transformer. This is the single phase AC supply with switch connection. And this is the voltmeter connected across the secondary of the auto transformer, and this is the ammeter connected in series, and this is the wattmeter current coil ML connected, and this is the CV, that is voltage coil of the wattmeter connected between this line and this line, and this is the single phase induction motor circuit. This is the main winding and this is the auxiliary winding, and this auxiliary winding is connected in series with a capacitor like this. So this branch is called the auxiliary winding branch, and this is the rotor representation, and this rotor shaft is coupled to the pulley like this, which is shown by dotted lines, and this pulley is covered with the belt like this, and the belt carries two spring balances. This is S1 and this is S2, and this is the beam supporting this belt, and these are the adjustment of load on the rotor pulley with the help of this brake rope. This is the general connection for the single phase induction motor to conduct the no load test and the blocked rotor test. Under no load condition, the ammeter range is 0 to 2 amperes and the voltmeter rating is 0 to 300 volts, and wattmeter is LPF wattmeter with voltage coil rating 300 volts, current coil rating 5 amperes, and we keep this belt loose, means this spring balances S1 and S2 show the 0 reading. For conducting the no load test, initially this auto transformer output terminal will be kept at 0 position. Then power is switched on here like this. Once it is switched on, power will be available at the input of the auto transformer. Now the output of the auto transformer is slowly adjusted such that the output voltage equal to the rated voltage of the single phase induction motor, which is normally 230 volts, and that can be measured with this voltmeter, which is MI meter. Once 30 volts is obtained, then note down what is the speed of the rotor and note down the ammeter reading and also wattmeter reading. That completes the no load test. Under this no load test condition, the voltmeter reading is represented with V0 and the ammeter current is represented with I0 and the wattmeter reading is represented with W0. Once the meter readings are known, then the no load impedance condition of the single phase induction motor can be obtained like this: Z0 is equal to V0 by I0. Similarly, the no load resistance R0 is represented by or obtained by W0 by I0 square. Once this is obtained, the no load inductive reactance can also be obtained using the formula x naught is equal to z naught square minus r naught square. Next, blocked rotor test on the single phase induction motor. The connections for this blocked rotor test is like this. Here, as usual, initially this auto transformer output is adjusted to 0, then here the input supply is given, then the auto transformer is varied such that when the rotor is blocked with the help of this rope and these adjustments, the ammeter shows a current which is called the rated current of the single phase induction motor. So this happens at low voltage of applied voltage. Under this condition, note down the voltmeter reading, which will be represented as VB, and the ammeter reading will be represented by IB, and the wattmeter reading is represented by WB. So once these readings are obtained, again the auto transformer output terminal is brought to the 0 position, then this rope is should be loose, means the load should be released on this pulley, then power should be switched off. Once the blocked rotor test meter readings are obtained, then the equivalent impedance, which will be represented as ZB, can be obtained like this. ZB is equal to VB by IB, and then RB, that is the resistance under blocked rotor test condition, is RB, is obtained as WB divided by IB square. Once ZB and RB is obtained, then the equivalent reactance under blocked rotor condition can be obtained using the formula XB is equal to root of ZB square minus RB square. Let me summarize once the no-load test and blocked rotor test conduction on single phase induction motor. So for conducting these two tests, the arrangement is as shown. There should be a single phase AC supply, and there should be a auto transformer, there should be a voltmeter, there should be a ammeter, there should be wattmeter, and this is the auxiliary winding branch, and this is the main winding branch. This is the rotor, and rotor shaft is coupled to the pulley like this, and pulley carries the rope, and rope carries the two spring balances, and the rope is connected to the beam, and the beam carries the two adjustment nulls to adjust the rope condition on the pulley. For no load test, the voltmeter rating should be rated value, that is 0 to 300 volts range, and ammeter rating should be 0 to 2 amperes, and wattmeter should be low power factor wattmeter, and we should apply the rated voltage by using this auto transformer, and note down all the meter readings, keeping the rope without loads. That completes the no load test. Coming to the blocked rotor test. So here the rotor should be blocked with the help of this rope, and then this wattmeter should be replaced with the UPF wattmeter, and this ammeter should be replaced with the high range ammeter, that is 0 to 10 amperes, and this voltmeter should be replaced with the low range voltmeter like 0 to 100 volts, and then keep this auto transformer in the zero position. When the supply is given, slowly increase this auto transformer output such that this ammeter shows the rated current of the single phase induction motor. Under these conditions, note down all other meter readings, voltmeter reading and wattmeter reading, and also ammeter reading. That completes the no load test and the blocked rotor test on single phase induction motor.